Right now, your phone knows exactly where you are. Within a few meters, anywhere on the planet, no Wi-Fi needed, no cell towers, just satellites, and some seriously clever math. Let's break it down. It was built by the United States military, but in the 1980s, they opened it up for everyone. The program started in 1973. By 1983, civilian aircraft could use it. By 1995, fully operational, with 24 satellites in orbit. Today, over 4 billion devices depend on it, every single day. So what's actually up there? Right now, there are 31 GPS satellites in orbit, spread across 3 orbital shells. They sit about 20,000 kilometers above you. That's way above the clouds, above the weather, above the International Space Station. Each one travels at 14,000 kilometers per hour and circles the entire planet twice every single day. So what does each satellite actually do? It broadcasts a radio signal, constantly, non-stop. That signal contains just 2 pieces of information. First, who it is. Second, the exact time the signal was sent, down to the nanosecond. The satellite doesn't know who's listening, it just keeps broadcasting, every second of every day. When a signal arrives, your phone checks, when was this sent, and when did I receive it? That difference in time, that tiny gap, tells it exactly how far away that satellite is. Here's the actual math, and it's simpler than you'd think. Distance equals speed of light, times travel time. GPS signals travel at 299,792 kilometers per second. So if a signal takes 0.073 seconds to reach you, that satellite is 21,884 kilometers away. Simple physics, insane precision. Knowing your distance from one satellite only tells you that you're somewhere on a giant sphere around it. Add a second satellite, and you're on the circle where those 2 spheres intersect. Add a third, and you're down to just 2 possible points in space. Add a fourth satellite, and your receiver eliminates the impossible one, your exact location, on the surface of Earth. This is called trilateration. GPS satellites carry atomic clocks, accurate to 1 nanosecond. Your phone's clock? Off by a millisecond or more. That sounds tiny, but at the speed of light, a 1 millisecond error puts you 300 kilometers in the wrong place. So that fourth satellite isn't just for backup. It's used to solve for your phone's clock error. Even with perfect satellites, GPS isn't flawless. Signals travel through the ionosphere, where charged particles slow them down and bend their path. That's called ionospheric delay. In cities, signals bounce off buildings before reaching your phone. That's called multipath error. In open sky, GPS is accurate to about 3 to 5 meters. With ground-based augmentation systems, it can reach centimeter precision. The American GPS system isn't the only one. Russia has GLONASS, Europe has Galileo, China has Beidou. Your phone likely uses all of them at once, for better accuracy and reliability. And then there's AGPS, Assisted GPS. It uses your cell signal or Wi-Fi to download satellite positions instantly. So instead of waiting minutes for a fix, you get one in seconds. So where does GPS actually show up? Obviously, navigation. Aviation autopilots depend on it completely. Precision farming. GPS guides tractors to within centimeters. Scientists track tectonic plate movement millimeter by millimeter. Every bank transaction gets a GPS timestamp. And yes, Pokemon Go. That too. It's invisible infrastructure, holding the modern world together. So let's bring it all together. Satellites broadcast who they are and when. Your phone measures how long each signal takes to arrive. That gives it the distance to each satellite. Signals from 4 satellites pinpoint your exact location, and the 4th satellite keeps your clock honest. GPS runs 24 hours a day, 7 days a week, whether you think about it or not. If this helped, hit subscribe. We've got more of these coming. See you in the next one.